Alright, one last video on Chapter 7. Again, we're continuing on with sampling distributions of sample means, and we're addressing one specific kind of issue. In the previous video, we said that if the shape of the population is approximately normal, then the shape of the sampling distribution will be approximately normal as well. But what is the shape of the sampling distribution of a sample mean if the sample is not taken from a normally distributed population? And does the sample size matter in this situation? Well, if the sample size is less than 30, then the sampling distribution of X bar will resemble the shape of the population. Like if the population is right skewed and I have a sample of size 10, then that sampling distribution will be right skewed also. But if the sample is large enough, it will be approximately normal. And we'll do some simulations in class so you can see how this works. Now, what is this concept called? It says this: the central limit theorem says that when n is large, the sampling distribution of the sample mean is approximately normal. So it's called the central limit theorem. It only works with sample means. It does not work with sample proportions, but only sample means. So the question becomes, okay, what is large enough? What makes it large enough to become approximately normal? Well, large, in this case, is when n, your sample size, is greater than or equal to 30. It's not very big, but that's large enough to make it approximately normal. Suppose that the number of texts sent during a typical day by a randomly selected high school student follows a right-skewed distribution with a mean of 15 and a standard deviation of 35. Assuming that students at your school are typical texters, how likely is it that a random sample of 50 students will have sent more than a total of 1,000 texts in the last 24 hours? So, we got to stop and think here. The mean and the standard deviation are given to us per student, right? If I have 50 students and I have a total of 1,000 texts, how many is that per student? So I got to stop and do that real quick. 1,000 texts among 50 students, that would be approximately 20 texts a day, right? That's what they're asking me here. I need to know, what is that per day per student to make this work? Now, it says, what's the probability of getting a sample of 50 that have sent more than a total of 1,000? So, in this case, it's going to be that X bar, my sample, is greater than 20 texts per, where X bar is the sample mean of my text, all right? All right, so now I need to know, okay, it tells me it's right skewed. So I need to know, is that large enough to know that the distribution of sample means will be approximately normal? So 50 is greater than 30, that's our magic number. That means that the sampling distribution of X bar is approximately normal, and I can notate it this way. 15 is my mean, and my standard deviation using my formula is 35 divided by square root of 50. And I know this by the central limit theorem. I do need to connect it to the central limit theorem. Got to make sure I mention the 30 boundary in there, otherwise it's not complete. All right, so now I know it's normal in shape. I know its mean. I know the standard deviation. So I can go back to the question. What's the probability that my sample mean is greater than 20? So I'm going to use normal CDF. My lower bound is 20. My upper bound is 10,000. You could use 1,000. That's fine. Mu is 15, base right here. Sigma is going to be this value right here because it's from a sampling distribution, and I get this value of 0.1562. So if I put my interpretation, I would say there's approximately a 16% chance that a random sample of 50 high school students send more than 1,000 texts per day.